Smart meter data management is not business as usual. Energy companies today collect data on a monthly basis. With smart meters, they want to move to collecting data at 15-minute interval. That means that they will collect in 3 hours what they used to collect in 1 year. Put another way, this represents close to 3,000 times more data. This is big data. We need to have a specialized approach to dealing with that volume of data and the querying required for this amount of data. Here's an example. If you start with 1 million customers at 15-minute interval, that means that you'll collect 96 million records every day. If you need to store 1 year of data in your database, you end up with over 35 billion records. Then if you assume that you do 3 queries per month per customer, that amounts to over 4,000 queries per hour, 24 hours a day, 7 days a week. Informix TimeSeries can help. It can help in space savings. Informix TimeSeries include a data type that knows about time-based data, and it can optimize the space. We've seen in some systems anywhere between 2 to 5 times less data in a Informix TimeSeries compared to a relational database. It can also provide higher performance. In some areas, we've seen close to 25 times performance improvement compared to standard relational. Finally, since you have a data type that knows about time-based data, you can also have a set of specialized functions that allow you to manipulate that data efficiently. So Informix TimeSeries comes with built-in functions that allow you to quickly put together the queries that are required for your business. And if that's not sufficient, you also have a toolkit available so you can add to the built-in functions, add your own algorithms within the system to really get to your answer faster. So let's look at these different items one by one, starting with space savings. First, by looking at a model, relational database model of the smart meter data. So here you have a table, a delivery point table that includes an ID, an address, longitude, latitude, and most likely other information, basically describing where the energy is being delivered. Related to that, you have the meter data table that includes the readings at intervals, in this case 15-minute interval. So the first thing we see is that we have 2 columns here. The first is the ID column that is really there to tie back to the delivery point table. When we look at having 1 year of data at 15-minute interval for 1 million customers, we had over 35 billion records. That means you have over 35 billion IDs here that are there just to tie the 2 tables together. Then you have the timestamp that identifies the time of the readings. In fact, each reading could have multiple values. In this example, I'm showing only one value. So what we see here is that the ID and the timestamp represent a significant portion of the element of the reading here. And after that, we need to create an index on the ID and an index on the timestamp. That means we basically double the amount of space required to be able to access our data. And if the index goes bad, you can't really access your data. You need to wait till the index gets rebuilt. With time series, it includes a concept of calendar and calendar pattern, and it keeps the data in order. That means that we can eliminate the timestamp and keep the data in order, and the position of the data tells us what time is represented at this position. So we can eliminate these 2 values, and then we get a table of meter data that would contain 1 million entries, just like the delivery point table, and each entry would have a column of time series type that would include all the values. We can take it one step further and eliminate the join of the 2 tables and put the data with the delivery point table, but that becomes a design decision. So I mentioned earlier that we see 2 to 5 times less disk space with time series compared to relational. That has some performance implication, and let's look at that next. First, space savings means less I/O. 2 to 5 times less I/O will give you higher performance. That will vary from system to system, but you could say that it should be proportional to the savings in space. In addition to that, less index access is also less I/O. So even if you kept your data separate in two tables, the index on the meter data table contains 1 million entries instead of 35 billion. So the index is much smaller and is easier to navigate and faster to navigate, less I/O, higher performance. But there's one more aspect why we get performance improvements sometimes in the 25 times range, and that's because of better storage organization. And that better storage organization also translates into less I/O and higher performance. Let's look at that in more details. The diagram here shows basically readings where each color represents a specific meter and each number represents a sequence number of the different readings. By definition, a relational database does not sort data on disk, and even when you query, you have to add the order by clause to be able to get your data ordered. But it goes one step further. There's no distinction here that says this data for this specific meter has to stay together. So it's mixed together within data pages on disk. And it makes it more difficult to get to the data because you'll have to do more I/Os to get to these different pieces. With Informix TimeSeries, it keeps the meter data in a time series all together. It doesn't mix the time series together, and it keeps it ordered. So you can imagine that if you have readings for 1 day of data, basically 96 readings, there's a good chance that it will fit into 1 or 2 pages on disk, and you'll only have to read these 1 or 2 pages to retrieve your data. And that's another big aspect of performance, the fact that having the data organized reduces the amount of work that the system has to do to retrieve your data, giving you a higher performance, and that explains the 25 times performance improvement I mentioned earlier. In addition to that, we have built-in functions. Built-in functions are useful to be able to write queries, write them faster, and have simpler queries. Informix TimeSeries includes over 100 time series related built-in functions. And if this is not sufficient, you can also use a toolkit approach, basically write your own functions that become built-in for you to optimize performance and have the ultimate flexibility in your system. So all the benefits of time series relate to space savings, performance, built-in functions toolkit. When we look at space savings and performance, that also has an impact on the size of the system, that has an impact on the power requirements for your data center, that has an impact on the size of your data center, and on the requirements for cooling of your data center. So the savings are not just because of space savings and performance, it has impacts all over the place. Built-in functions allow you to be more flexible, to be more agile, to get to your end result, to answer the needs of your business, and the toolkit takes it one step further where you can make sure that you have the exact processing that you want there. So Informix TimeSeries gives you all these advantages, all that in a mission-critical enterprise database system. To learn more about Informix TimeSeries, contact your IBM representative or take a look at this website here, Informix TimeSeries for meter data management. Thank you.